Okay. As you know, I'm going to be speaking for 12 and a half hours. You saw the thing, right? Okay. So I'll start with uh, Multigress. And it all began here. Yeah. A few months ago, I sent a LinkedIn message to Copper. Why did I decide to do this? And how did this happen? Actually, before this, I was happily enjoying a sabbatical, being a total nobody and completely enjoying it. And but then I had started to itch, I got to do something. I want I've been on a sabbatical for like 3 years. So I want to do something. So I started doing some consulting, advisory work, and noticed that this Postgres thing, momentum, the large number of people are using it. And I wonder what they're doing for scaling, And one of the companies I work with, Metronome, actually, I think their head of technology is here. If he made it through the gates, I heard Cosmo, are you there? You want to wave? No, Cosmo? Oh, there he is. Okay. Yeah. So I was working with them. They are a real-time metrics and billing company. They run at massive scale. They have like a 30 terabyte database. And I'm like, does this, you're running a 30 terabyte single instance database? Yeah. Okay. And it scales? Yeah. And it keeps working. Okay. Maybe there's no scalability problem, at Postgres. Just as I was thinking that, they had their first outage. And it was a pretty highly technical outage. Actually, they've blogged about it. I recommend you read it. It's a very interesting blog post. So that's when I realized, no, there is a limit. At some point of time, there is a cliff. There's a dead end after which you cannot scale Postgres. So the alarm bells went off, and I realized that something like Vitess is needed for Postgres, and I'm going to start doing this. So as you know, I'm actually from the MySQL world. I don't know anybody in Postgres. So I start Googling, it's like, who are the players in Postgres? What are the companies? And I find Supabase and a few other companies. And I said, who are these founders? Like there's Koppel and Ant, like they are in like Singapore. Oh, okay. And then I look at my contacts, not a single common person that I know. So what do? LinkedIn message. And guess what happened? No response. Like, okay, what do I do now? And so I start sending out messages, to let's find somebody common. I said, worst case scenario, I'll just go start my own company. So I was actually starting to execute plan B, like starting to, talk to co-founders and stuff. And I'm also firing off these messages saying that, do you know these founders of Supabase, etc., etc. At some point of time, I actually get an email from Ant. I said, oh, yes. So I go open the email, and it says, Dear Sugu, your database has been idle for 7 days. We are going to archive it. I'm So I'm like, okay. Finally, I reached this guy, Phil Eaton. He says, I know Koppel, I'll put you in touch with them and with him. So finally, I meet Koppel, and, here I am. So the moral of the story is, if you want to meet Koppel, talk to Phil Eaton. He's your guy. So, okay. So let's now talk about Multigress. So what is Multigress? As Koppel said, it is Vitess for Postgres. I don't know how many of you have heard of Vitess. Okay, cool. How many of you have not heard of Vitess? A lot of you. Okay, don't worry. I will cover like the main points of Vitess, and you can go read more about it later. So first of all, why are we doing this? Ant talked about 4.5 million users. I can tell you one thing. Some of you, those 4.5 million people, are going to become extremely successful, extremely big, ludicrously successful, So what my job is to make sure that Postgres continues to scale for you until the end of times, So Vitess itself has a nice track record. So I know how to do it. We just have to make it happen, It can scale to like petabyte scale, millions of QPS, has done it like no other database has. So I know we can do it. And the thing that got me anxious is I'm looking at people doing this and none of them seem to be going in the right direction. Says, I got to do this, So, but then the sharding is only half the story for as far as Multigress is concerned. What Multigress is good at, he's actually taking care of your database. And that actually starts from day one, like the day when you start launching your first Postgres instance. And as I said, the most important part, actually, this was actually a very important part of the conversation, is when I talked to him saying that, I want Multigress. Actually, he named it, by the way. So we spent a lot of time brainstorming on the names. We came up with some cool names. Unfortunately, we couldn't use them. But the thing I wanted to tell him, no, I want this to be open source. And then the first thing he tells me, I want this to be open source. Say, yes, okay. That's good. So Multigress will be open source. You will be able to take Multigress and run it for your own production, just like Vitess. Like there are a large number of people that run Vitess in production by themselves. You should be able to do the same thing with Multigress. So how is Multigress going to help you from day one? So if you first go to Supabase and sign up, you get a database. So that's the bottom box that you see on the screen. You get that Postgres instance. And under that Postgres instance, you have actually a mounted storage, something like EBS, elastic storage. So why do you need that elastic storage? Is because your instance may crash. If it crashes, you don't want your data to be lost. And so EBS basically is replicated storage, makes sure that you never lose your data. So worst case scenario, you restart your Postgres instance and you continue with serving traffic. And typically, many of you already know about PG Bouncer. Everybody, it's a mandatory thing that you have to learn about when you start using Postgres. You cannot just directly connect to the database. You need a bouncer, just like Phil Eaton for Koppel. So that PG Bouncer makes sure that you don't overload the database. So Multigress will take care of that for you. That is what we call as the multipooler. And there's also the multi-gateway that is on top of multipooler. Why do we have these two layers will become obvious when as I go talk more about it. So multipooler is more like PG Bouncer. Multi-gateway is more like supervisor. So multipooler handles the connection pooling and multi-gateway handles the user connections. So that's how it separates. And what is better about Multigress is that it's going to be multi-threaded, which means that there is no CPU limitation when you use it. Typically, once you max out a PG Bouncer, then you have to start playing with multiple of them. It becomes a big headache. So that headache doesn't exist. And another thing, this is something that we did in Vitess pretty early on, which I have not seen being done in the Postgres world, which is separate the pools that connect to the database. So multipooler will have, actually in Vitess, we have 3 pools. In this, we are going to only have 2, and we may introduce the third one if it is needed. The 2 pools are the transaction pool and the read pool. So what that gives you is the ability, like if you suddenly overload the database with transactions, your reads can continue to go through. Like in a typical transaction, in a typical pooler, if you overload it, all the connections get taken, then everything gets blocked. Whereas in Multigress, your reads will continue to go through and the transactions will get funneled through the limited pool that you have. And that actually keeps the database healthy because a larger number of transactions typically just destroy the database. So you can actually tune your pool size to make sure that it never kills the database but continues to keep it operating at maximum efficiency. So that is, and this is this is well tuned. We know how to tune this very well, and to the extent that it's a common thing that happens. These databases have this weird behavior: is that once you push them over the limit, even if you reverse the traffic, they don't recover. They just stay broken. And the best way to do it is to make sure that you don't push it over the limit, and the pooler will take care of that. And in the case of a single instance, all these things can just run in one box. So it's not going to be super inefficient. Okay. What else does this give you? This gives you these components, unlike what is there out in the market, will all have their own parsers, which means that they will know what you're sending. They will know they can do things with your query. The one immediate thing that you will get is it will normalize your queries and report numbers about how they are. So what that means is that, let's say your database is running happily, and then suddenly things slow down. You can immediately look at which queries changed, and you'll know how to fix the problem. This used to be my go-to troubleshooting thing. Like as soon as there's a database outage, okay, show me the queries, and boom. 90% of the time, the culprit query can be found out by just looking at this report. All right. So this is kind of imagine this being your journey. You started with Supabase and you're happening. The next thing that you'll find is that, your primary database is getting slammed with traffic. And the first thing that people typically do is scale it out by splitting reads and writes. So then you add replicas and want to send traffic to the replicas. So in this actually already exists in Supabase. What Multigress will give you is multiple ways by which you can configure your replicas based on your convenience. Like, for example, you can have a separate endpoint for replicas, a separate endpoint as your primary. You can actually treat the whole thing as if it's a one Postgres server and say, I connect to primary. The replicas will appear as if they are a different database within the same Postgres server. So kind of a convenience. There's actually a third way you can do it, which is I want consistent reads from the replica. So what Multigress will do is every time you write, it will remember your write position. And if you do a read, it will make sure that the replica has that write so that you get consistent reads. You get best of both worlds, like both consistent data as well as load balanced. So, and scaling. There are some trade-offs here because if the replications start to lag, then these reads are going to get slow. So, but it's up to you. Vitess gives you the tools and you use them the way you see them fit. What else do we have? So at this point, you are probably serving in the hundreds of thousands of QPS. And if a database goes down, users will start to notice and start to complain. You're no longer the indie developer. You are now a real company. And you want to be accountable to your users. This is when you need high availability. So here we introduce another component called multi-arc. And in multi-arc, multi-arc stands for multi-orchestrator. And what this will do is if a primary fails, it will immediately fail over to one of the standby replicas and continue to serve traffic. This sounds very simplistic, but it is one of the hardest problems in computer science because this is actually a consensus problem. And we have beaten this problem to death. With in Vitess, you can configure Vitess to run 5 nines of availability, which is the gold industry standard. And we are shooting for the same thing for Multigress, and I'm pretty confident we can do it. And we've actually, there are some real cool magic that we can do with this that you would not get anywhere outside, which is when there is a software rollout, these small boxes that you see, they are actually a trio of multipooler database and the service. The multipoolers are constantly talking to the multi-gateways. So when you do a rollout, the multipooler, what it'll do is it tell the multi-gateway, hey, I'm being restarted, so hold off your traffic. So multi-gateways, they say, okay, I won't send any more traffic to you. The multipooler will finish your transactions and then transfer its primary ship to another one. And the multi-gateways receive a notification from the new primary and then send the traffic there. The user will see no errors at all. And this system, actually, we've built it to the extent that you can totally abuse this. Like, there was a time when, like, when we were at Google, we used to import data from, like, Vitess was an open source project. You used to make all kinds of changes and then import it into Google, run some tests, and then put it in production, and it'll, like, break. Like, especially this failover thing. So I got totally mad. I said, I don't want to ever see this happen again. So I told the test person, every time it comes in, you have to do 100 failovers, and none of them should hang or, get stuck. So we did that. And after that, we have not seen any hanging. And this now system is so robust that you can totally abuse it. No problem at all. And that's in the Vitess case, and you'll get the same thing with Multigres. Finally, last but not the least, I talked about EBS being a replicated storage. What is this? This is also replication. So why run replication and use replicated storage for your data, right? Get rid of the replicated storage, put everything on local NVMe. The NVMe is about an order of magnitude faster. So if all you have to do is now move to NVMe, you get a huge performance boost, nothing like you ever seen before, and you get high availability, 5 nines of availability. So this actually will give you an instant boost in terms of what you can do with. We actually don't know how big of a workload you can run, so it'll be a fun exercise for us to find out. We take a sip of water. So far, so good. Everyone with me? Okay. What is next? So your traffic is growing. Now you're pro. Now high availability. You have 5 nines of availability. What is going to happen is your users are going to expand. They are going to be across the country, across nations, and this is where then you can tell Multigres, I want my replicas to be all over the world, different zones, different regions, and this click of a button, replicas can spin up anywhere in the world. And those replicas will have their own local endpoints, but remember, it's just one database as far as we are concerned. And if there are any writes, they will get redirected to the primary, so make sure that everything stays consistent. So here you get one cool enterprise feature that is unique, that is only available in Vitess, that will be available in Multigres, is what we call is a durability policy. So as an enterprise, you want to decide what is your tolerance to failure. Some people may say, if my data is across zones, that's good enough. Some people may say, our data is very precious, we want it to be across regions, which means that as soon as you commit, Multigres will make sure that your data reaches that location before it says, yes, your commit is done. And you can even go across country if you feel like. There's a price to pay, obviously, the latency, but Multigres can. The beauty of this is, this actually does this for you, respecting all the laws of consensus. Which means that you will never lose your data and it will never diverge. Like the entire cluster will remain consistent. Okay, moving on. So under the covers, it gets pretty complex. But the beauty of all these things is all these components are like living beings. They are all talking to each other and making sure that the cluster stays up. But it does get kind of complex. So these These diagrams are actually directly taken from the architecture document, so you can go back and refer to it if you want. So I just wanted to show you. So imagine this, and then this being divided across different countries. So all these things for you just appear as if just one single Postgres. So this is when, around this time, I'm giving you these data points based on what we went through when we scaled YouTube. This is when you will max out your primary. You've split your reads. Your reads are going to all the replicas, but the traffic that you have to send to the primary cannot be moved out anymore, and it is now maxed out. This is the end of the road for you. So this is when Multigres will say, okay, we'll help you split your data. The first thing you do is you don't start with sharding. The first thing you do is actually identify a few tables, move them out of the main database. You split your database into smaller parts. So Multigres will do that for you automatically. And then afterwards, you will end up with some tables that are kind of enormous. And those you eventually shard. When you do this, at this time, you will be actually thinking, you will be starting with the thousands of nodes in your cluster, and you should be eventually hitting like in the tens of thousands of nodes. And this is comfort zone for Multigres. So you can do this, and it's going to be likely all over the world. And the best thing for you is that it's still one Postgres. And under the covers, it's like a whole bunch of Multigres Postgres instances just presenting to you, just like the original Postgres, that small thing that you started with, except that it's going to be at a massive scale. So where are we in the project? I see that some of you know what's coming. We are kind of in the circle drawing phase. All we have to do is draw the rest of the owl. Actually, we are slightly ahead of the circle drawing phase. We just landed a big pull request, 300,000 lines of code, vibe coded by one of our top engineers. Does the entire Postgres parser. So we are making good progress. We actually can, you can go to Multigres GitHub, download it, you can build it. It'll bring up all the components. They don't do much, but all the components come up, they talk to each other. So the basic building block is there. So we'll actually start delivering some stuff soon. So in summary, what are the enterprise features that Multigres has? One is performance, NVMe performance. The other is scalability, sharding, and replica reads. You get the flexibility of these durability policies, query routing. You get HA, 5 nines of availability, and you get insights, observability, where if there is trouble, you can immediately find out where it's coming from. So that kind of concludes my talk. I want to bring up a couple back because he has some questions to ask me.
Well, I think we've got a bit of... Is this working? I think we've got a bit of time, so I'm going to ask you some questions, and maybe actually we might even have time to open it up to the floor. I thought one of the coolest stories was, I guess because it's super relatable, was the YouTube story where actually it all started. Of course, everyone here knows YouTube, and it's kind of a huge thing, but you were working on it and you were on the inside when you hit some problems, and the way you told it, maybe you hit some problems so much that they couldn't even roll out features because you were literally becoming the bottleneck.
Yeah. So this is something that many people like. When you talk to people, they say, "Oh, I can run this on a key value store, and I can do this." So it is not true. The problem, by using storage that is not optimal, you subconsciously limit what you even like a PM comes and asks you for a feature, you say, oh, no, I can't do that, right? But if you had a better system, you can do it. So subconsciously, the kind of products you roll out, the kind of features you roll out depend a lot on what the database can do for you. And specifically at YouTube, what happened was at some point of time, our database was so maxed out that any developer that came to a DBA asking, oh, I need to create this table, the DBA's answer was, the answer is no. What would you like to do? Because you can't add any more data to the database. So the answer is no. And the developer would have to find workarounds or ways to convince them. And eventually it affects the velocity of the company. So we had actually reached that point. And once we did the sharding, and it took me a long time to convince the DBS, you don't have to say no anymore. You do the opposite. You invite them, you ask them to do more. And we were at like about 16 shards when we rolled out Vitess, because we couldn't reshard until Vitess was ready. Within a year, we went from 16 to 256 shards. And the features at YouTube totally exploded because there was like no limiting factor anymore. Anybody could, like, all you had to say is, I want storage, I'm willing to pay for it. Okay, you're welcome. No, we'll just keep sharding as you keep coming along. So that's you don't notice that, like, if you don't have that ability, that database controls the future of the entire company because you just cannot roll out features. They are like so limited.
Did you already explain what shards are to the team? Does everyone know what?
Oh, yes. By the way, we have the Vitess tech lead, Deepthi, here. Wave. Oh, there she is. Yeah. So she joined us and will be doing HA for us.
Nice.
Yeah. Sorry, I had it on my notes and I skipped it.
Shards actually has quite a cool story behind it. Sharding, if you don't know, is where you take a database and you split it into different fragments, and it should still then feel like a single database. It actually, correct me if I'm wrong, maybe this is mythical lore that I've made up or something like that, but it came from gaming because of the concept when, I don't know if any of you play these massively online games, but at some point you get a server that cannot host enough people. And so what they did was they just created a narrative like, oh, this world, I think it might have been Ultima or one of the worlds, they just, in the lore, created this crystal world that's split into, sharded into many fragments, and then you would visit one of the shards inside the world, and they kind of made it part of the narrative. So it's kind of cool that the database ecosystem has adopted the same term.
Yeah, so the one thing about sharding is you have to be very careful about it because if you look at databases, the core property of a database is ACID, and the simplified form means ACID means all the data has to be together. That's the meaning of ACID, And sharding means that you are separating it. So how do you get the best of both worlds is an art. And more than an art, the database has to have you have to be able to tell the database, these rows must stay together and these rows can be split apart. And Multigress, like this took a long time for me to think about it and solve. Multigress has the ability where you can actually formally specify this relationship and this constraint as a relational rule, and which will then ensure that all related rows end up in one shard. So which means that then if you send a query, then the query engine knows, oh, all these rows are together, send it to this one shard. So that keeps it, that allows you to scale infinitely while still having the experience of a small database.
And maybe to give a sense, I'm sure everyone knows roughly the size of their database in the room. Maybe to give them a sense of what sort of scale you've seen. You said YouTube was 256 shards, but what does it go up to? What are the largest clusters that you've seen?
I think I've seen in the 500 to 1,000 ranges so far. I know it can go higher, but that's what I have seen. there are some pretty big companies that already run Vitess. There is Slack, which is fully running on Vitess. There's GitHub. Um, some of you may not. Bloomberg doesn't talk much about it, but Bloomberg runs on some of their stuff on Vitess. And from what I hear is they run at a pretty massive scale. They may actually be bigger than even Slack. Yesterday, I found out that Uber runs tens of thousands of nodes of cluster in using Vitess. So there's like quite a number of large companies running.
And you've seen obviously a bunch of scale. Maybe for the people in this room, do you have any tips or lessons? Obviously, use Multigress will be one of those tips. But as they're scaling up, what do they need to keep in mind about their scaling, their database? What should they think about?
So what I would say is the flexibility that you have when you started off, like all those cool features of Postgres, you will most probably not be able to use all of them once you're scaled out. You'll probably realize it even as your database grows, you're going to start giving up on certain things because some of those features are not scalable features. So some of them you will have to abandon. Like some things you can get by just adding indexing and a few things. Some things just won't scale. And as time goes, like for example, I read somewhere that there are certain query patterns that are very that RLS just cannot handle. The row level security cannot handle. So at that time, you have to make a choice. You either drop the query or drop the row level security. And same thing happens when you shard. You will see that once you sharded, you have to make a decision about what lives together. That also dictates like what queries you are going to use that relate to the data that is separated. So if you abuse that relationship, the system will not scale for you.
Okay, let's switch gears to open source. Obviously, when you came to me, you had in your brain that this was going to be open source. I'm glad that I said it first. But why open source? Like, why do you care about making this open source? Why not make it a commercial thing for a company? You could have built a startup around it. Why did you care so much about making it open source?
So when we first decided to build Vitess, Google didn't even know that we were building it. The two of us decided, we should open source this. So therefore, we didn't even check that thing into Google repository. We ran it on our home directories. And the reason why we did that was actually very selfish. We said, no, this is going to be a tough thing to build. I don't want to go out and rebuild this for every other company that might work at. So let's not, And finally, we got permission from Google, and we then exported the whole thing into open source. So that was one reason, and the other reason later was when YouTube started depending on it. For me, it's like if YouTube is the only company that uses this product, this will die. There is because nobody wants to use bespoke technology that is this complex. Eventually they are going to say, no, let's look for something that is industry standard. So the only thing we can do is make sure that this is an industry standard. So I want to make sure that Vitess gets adoption everywhere outside. And lo and behold, a time came when the Vitess's existence got challenged. And at that time, we could say, you know what? Vitess now is used by multiple companies. I can go start my own company if I want to. So since then, I have always been saying that, there are some technology that has to be open source. Like Postgres, for example, right? It has to be open source for it to thrive and do well. And Multigres is in the same category. So it will not thrive if it is not open source.
I guess then it begs the question as well. You could have done it open source at many companies. Why Supabase?
Why Supabase? Actually, let me talk about why I did not do the startup.
Yeah. Okay.
Why did I not do the startup? Is when I ask myself, uh, what do I want from this project? What I wanted from this project is the cleanest path to success for the project. I wanted velocity and lack of distractions. Um, if I did a startup, if you right now, I'll be busy talking to VCs, trying to raise money, or I might have raised money. I'll be trying to hire people. If not hiring people, I'll be busy, managing them. I'll be busy drawing out business plans. None of that distraction, which is why I started looking for, people like you. And I'm very happy I found you. And um, it could have been I had some constraints. Like, for example, if someone said not open source, I would have said no. But I was very pleasantly surprised to hear that you and I shared the same values on open source. So,
Well, I'm very happy to take on your suffering and chat to all these VCs. What fun. Okay, so what about then Postgres versus MySQL? What do you think? What are the differences? What have you been surprised about in the community? They're obviously both open source as well, both very popular databases. Now Postgres is having a moment, and I think it'll continue to have a moment. What are you seeing coming from the other side?
So for me, Postgres was like a black box. I didn't know anything about Postgres. I only knew the MySQL community. It took me a long time to get to become part of the community. But also MySQL, there is still a clear separation between developers and users. And that I don't see exist in Postgres. There's a nice continuum between developers and users. I was actually very intimidated about the Postgres. I was very scared of entering the community because I've heard of these, big wars and stuff where people like welcome me. I was very pleasantly surprised. Everyone welcoming. I said, actually, the image from the outside looks always intimidating, and I'm very happy to see, and also humbled, like how welcoming people are. But I have to say, Postgres needs to win because it has the best values and it needs to be defended. So from that point of view, I definitely want Postgres to win.
Compared to, yeah, that's great.
Yeah.
Me too. So that's great. I guess, like, what do you mean by it has the best
license? Like
license, yeah.
Definitely. Like in Vitess, we had a struggle that we could not. There are some features where we had to use the dark. What is that thing? The reverse engineering approach. We had to observe behavior because of its license. We could not now look at the code to replicate its functionality. So those challenges don't exist with Postgres.
Yeah.
Yeah.
I've had a long time to think about this particular thing about Postgres. I get asked all the time, will Postgres win? And for me, I'm very biased, but I actually think about open source in general. What makes a good open source system or tool? And we've been assessed throughout the years in terms of open source. And I've realized that there's kind of three criteria that people always assess you on. The first one is the license. And so is your tool very liberally licensed? An OSI compliant license is what you call it. So Supabase, for example, checks that box. We have all the licenses. Everything is available. The second is self-hosting, which if you're not self-hostable or not enough, or it's not easy enough, then people will actually think that you're not very open source. I'm actually really happy. This week we announced that we brought on Andre to lead self-hosting. He's the co-founder of Nginx, and he's just going to focus on self-hosting to make it even easier to self-host Supabase. But then the third one, which is why I think Postgres will win, and it's very difficult for most other database tools. what you want from a really good open source tool is one of two things. It happens in three ways. Either there is no commercial support and you're asking for donations. That's very pure, and open source fanatics love that. The problem is you can't support it indefinitely. So then the second part of the spectrum is there's some commercial support. So for example, Supabase develops tools for Supabase. This one's good, but it's not as pure in open source as some people like it. As soon as you have any commercial interest attached to it, people kind of see it as dirty. But then you go to the other side of the spectrum and you've got Postgres. And the thing that makes Postgres special, it's one of the only tools that has no commercial entity directly attached to it, but many commercial entities attached to it. And all of the hyperclouds use it. And in this way, it'll continue to win, because if one of the hyperclouds do not support it, then they'll fall behind because it's becoming so popular. So in some ways, it's like a prisoner's dilemma type situation where they have to support it and have to continue supporting it so that they can have the best offering on the planet, and it pushes the whole ecosystem forward. So it's really cool, and that's why I think it'll continue to win. I can't see any other database now that'll have this dynamic emerge in the next 50 years. So yeah, pretty cool.
Yeah. So before you go, I did want to ask you one question, which is, well, that LinkedIn didn't work, but we finally got to meet. What was your frame of mind? Like, what were you thinking? By the way, I was like a wreck. I was like, I think this is not going to happen. And I was like looking at plan B and like, and so what, like, I want to know what you were thinking.
Well, it's quite, I mean, I get approached a lot, as you can see from the LinkedIn messages at any one time, of people who are maybe wanting to do something, or we're a very collaborative company as well. We try to, one of our principles is to support open source ecosystems rather than build our own. It's one of our ways of giving back. So I honestly did not know what you wanted to do, and I just figured you wanted to chat. You obviously came from the MySQL ecosystem, so I was very open to it. But it's one of those funny things that the timing, probably if you had been, say, approaching us now, you know, we're going through this re-architecture internally. And if you had approached us now, I just would have said, too late. We're already far through, you know, this re-architecture, and we're too busy with all the AI builder growth and everything that's happening. But you came at kind of this perfect inflection point where we're going through the re-architecture, and now it meant that we can kind of make those adjustments towards Multigress and make it happen. So it was just one of those things where I think we probably met, and then within 2 weeks, we were already working together.
Yeah.
So I don't know exactly what happened, but I just knew when I met you and we chatted about what you had been doing in your sabbatical, and you said, I'm going to do it anyway. So I was like, this guy wants to do this. This is not like a drive-by. I'm going to try and see what it's like. You knew exactly what you wanted to do. You're a founder, an ex-founder. We have at our company, I think now 30 ex-founders, and there's a criteria that has to exist for ex-founders to really thrive within a company. They have to know exactly what they want, and we have to be able to give them a lot of autonomy, and they've got to kind of own a whole part of the ecosystem of Supabase, which is quite clear here. You can do that, and we're not going to tell you what to do. You know what to do, and we just need to support you as much as possible. So in many ways, it doesn't work with founders because, you know, a lot of them see working at a company as not as cool as running a company. But you know that sometimes, like, my job is less cool than what you get to do day to day. So in that way, you're egoless. You know exactly what you're going to do, and you don't care about my job. You just want to get to work and build something cool for the entire planet.
Yeah, I love my job.
So then maybe that's a good time to pitch. When's this available, and what type of people do you need to help build it?
By the way, I have an awesome team. Like, it's actually one of the best things. It's like one of the best teams that one can ever imagine. It's like they are like you saw that pull request, right? I can't think of anyone else who can pull off something uh, of that magnitude. 2 months work, no? An entire Postgres parser, and each and every one of these team members is like that.
And the results are great, right? I think you're showing me some of the benchmarks that is done.
Yeah, and we are just getting started. So that's just our initial benchmark. So we are going to make some more tuning changes, and I don't know what we are going to get. It's going to get a lot better.
Cool.
Yeah. So I'm thinking maybe add maybe a couple more people to the team, and probably that's going to be it. By the way, we have always, even Vitess, even in its biggest form, we might have had like 10 people. And I pride myself that we've competed against organizations that were an order of magnitude. Like Vitess was competing against Spanner within Google, and we were 10 people. Google had 300 people on Spanner, and we were still matching the feature. We could still like outperform Spanner in many scenarios.
Why do you think that matters? Why do small teams outperform the big teams?
I think software is software, and you have to know what to focus on. And having a small team makes you focus on the right problems. If you have too many people, I think they just start to get in the way of each other and can't make as like in our case, not a single person would interfere in another person's path. Everyone was 100% full productivity, completely on their own track, and the system was well designed such that the integration points were well defined. Otherwise, you owned your entire feature.
Yeah.
Yeah.
Cool. Okay. Well, we don't really do timelines at Supabase, but if you've got any rough guidelines around, I'm not going to hold you to it. Just
Very soon would be going to.
okay, very soon. Multigres.
No, actually, I think early-ish next year we should have something. We should have, like, you can start playing around with things right away, and I'm pretty sure Multigress will serve its first query very soon, maybe within a month or two, and then which means that, but something that is production ready. We don't know. We'll probably HA probably sometime next year.
Cool.
Is probably what we are looking at.
Cool.
Yeah.
Nice. Well, I think we've got about 10 minutes. I think we can open it up to the floor if we want for a couple of Q&A. Are there any microphones? All right. Go for it.
Hello. Hi. My name is Andrew. I'm a co-founder of Dreamlet AI. But I want to ask you, Sugu, what do you think of PlanetScale's Postgres offering?
What do I need?
What do you think of PlanetScale's Postgres offering?
Oh, what do I think of PlanetScale? It's good competition, and it's good to have rivals. Yeah, so we'll see. We'll see how it pans out. But I think it's good for the industry to have competing projects.
Hey, I'm Dan from Interweb. Good to see you guys. On the similar topic, I believe they're also using a Kubernetes operator, and I noticed that there was a Kubernetes operator of some sorts.
I can't hear you.
Oh, okay. Maybe I'll speak louder this way. So I noticed there was a Kubernetes operator in the architecture diagram. And to go off the previous question, I believe PlanetScale also is doing a Kubernetes operator. Is there a particular operator you guys are building? I know the Cloud Native Foundation recently came out with one. Just curious your thoughts on which operator and if that's something you guys are also investing in and supporting.
Cool. So we are going to build our own operator. So that we are going to do. The way Multigres is architected, is in the original picture you saw on the side a box called the provisioner. The first picture that I showed you, that is the operator. And this architecture is such that you can replace that provisioner with anything. Like, for example, if you don't want to run it in Kubernetes, you can replace that with the Terraform provisioner, and it will do the same thing for you. So that's that pluggable architecture that Multigres has. But we will build definitely the Kubernetes operator, and it will be open sourced. And so you can actually, if you have that, it will be very trivial for you to get a Multigres cluster running. Does that answer your question? Yeah. Yes, here. Yeah.
Hi. Were there any specific technical challenges that you encountered when building Multigress that you didn't encounter when building Vitess?
Whether can I repeat? Were there any technical challenges with
that you've encountered when building Multigress that you didn't encounter when you built Vitess?
That is different from Vitess? Oh, that's a very good question. So there is a lot of learning from Vitess. We are going to be copying a lot of code from Vitess. The biggest challenge, biggest difference in terms of challenge is Postgres compatibility. So what we are going to shoot for is full compatibility with Postgres. So Vitess is not fully compatible with MySQL. It tries very hard, comes very close, but it is not fully compatible. So if you want to migrate to Vitess, you may have to figure out, you may have to drop some things, make some changes. So if you're it may not run as is. Our goal is to make sure that if it runs on Postgres, it should run on Multigres. And that sounds very simple, but it's a very difficult problem to solve. But we are taking on that challenge. We'll find a way to make it happen. Yes. There's actually one other person after him who's here.
I just wanted to say to you and the whole Supabase team, as a founder, solo founder, technical guy, I chose Supabase when Supabase went live. And my whole thing is, I don't want to have to think about the database. I don't want to think about scaling. I don't want to think about sharding. I just want to go and coming here and hearing you guys, you be so excited, Sugu, about doing this for your life. I'm like, yes. Has to be your life stuff.
Thank
you.
Okay there. My name's Lee. I'm the founder of Dynamite, and I actually have kind of the opposite problem, being an engineer by trade. And as a solo founder, what I end up doing, having a technical background, is prematurely optimizing. So I spend 95% of my time thinking about scale issues that I just don't have yet. Somebody released about a year ago. So I want to thank you for that you're clearing up 95% of my time that can better use to go talk to customers. My question is that there are certain moments in the development of technology where the hockey stick starts to take off. One of which was the Homebrew Computer Club in the late 70s that brought computers to a new class of people when the microcomputer was invented, and there was an explosion there. It seems like right now is the Cambrian explosion of SaaS, and I mean, it really seems like this is the room of what the next 10 years of growth and explosion are going to be. What do you think the effect of the services and the accessibility that you're making for indie developers is going to have over the course of the next few years?
I can't speak for the whole software industry, but what I have felt is that this whole thing that happened when 10 years ago, when everybody went to NoSQL, I thought that was a big mistake. And the reason why that happened is because at that time I felt guilty. Us database people did not listen to the community. Like in the 2010s, right? Hard disks exploded. Like your ability to store data went up by 2 orders of magnitude. And the database people, ACID is what is important to us. We are not going to compromise on that. So we don't care what your data size is. We will not compromise on some of these things. And databases actually failed to scale. And that is what caused people to go to NoSQL. And that problem is likely to happen again. We should make sure it does not happen, right? We should make sure that when people are on a database and want to scale forever, we have the right solutions and tooling to make sure that they stay on it. Otherwise, it's going to be history repeating itself. And again, is eventually companies not being able to grow as fast as they could, because if you have an inferior data store, your features are going to suffer. So that is what I think we owe to the industry this time. Make sure that that mistake does not get repeated.
I'll just add on to that one, because I think And had in his slides that we've got now 1,000 YC companies. And for us, we've really been intentional with our tagline, scale, build in a weekend, scale to millions. And we had to start with ease of use. For a long time, we've wanted to build a database company, but the truth is many have tried and failed to build database companies. And usually they start by thinking, I'll just build a bigger, better database. Whereas we took the opposite approach. We always said, let's make it really easy for people to use so your one-person team can scale. And if we do this over the course of a generation, then we'll be the database platform of the future. So that's what our promise is, Ant and I. We're here for the next generation of builders. And as their profile of developer changes, whether it's AI, whether they need different scaling, whether they want to scale smaller or bigger, we'll do that because we're going to continue to service whatever that looks like.
There's one question there. Ant, you want to come up here? Some of these questions you should be answering. Yeah.
We've got 1 more minute. So if you've got a question for Ant, then you got 1 minute.
All right. Thank you, Sugu. It's amazing that you're building this. One question, though. How could we leverage this on the Supabase eventually? Like, are you going to make this opt-in, or what's the plans to incorporate this?
Yeah. As with everything, we'll make it seamless. So it'll be kind of a progressive adoption. You'll start exactly like you are today. Then you add replicas, and then you can eventually, if you want, start sharding your database. So it's just going to be, as you scale up, more and more things get adopted. Of course, another piece of it is not just splitting your database. It's also kind of like an operating system where you can see self-healing, observability. You'll see a lot more of this leak into the dashboard. Even in the next 6 months, we're running internally what we're calling a defrag period, where we're kind of taking everything that we've got and now we're running a defrag, making it all as seamless as possible. So controversially, we might not even do a launch week at the end of this year. We'll just focus on getting all of these features working really nicely together.
There's some questions there.
Hello, my name is Ethan. I'm the solo founder on Tile Studio, that tool that helps you make impressive product demos. So my question is not only about database, but I'm a huge fan of Supabase. So I use AWS a lot, but now I feel like I only need AWS when I need container services. So I wonder, do you have any plans to have something like ECS, Fargate on Supabase? So I feel like I can just get rid of AWS completely. So thank you.
We hear this surprisingly a lot, as you can imagine. I think Well, you've seen what Sugu's trying to build, right? This is already a very hard problem. I can see the appeal of trying to solve many, many things, and we do several other things, auth and functions and things. No plans is the pretty clear line on this one. We need to solve databases, and there's still so many problems to solve in this space, and this is going to take a long time. So, yeah, that's the line there. So, sorry to disappoint. Yeah.